t is equal to root 3 minus I. So x is equal to root 3 and y is equal to here minus 1, which is less than 0. Note that this is less than 0, so we will put the sign negative between, as we have discussed last page, that if y is negative then the sign between is negative. Okay, here, so the square root of x plus iy, if y is negative, is given by, as I have written in the last page, is by plus or minus root of mod z plus x divided by 2 minus, because y is negative, I mod z minus x divided by 2. We have x is equal to root 3, but first we need to find the modulus of z. So here modulus of z is equal to in root x square plus y square, that is equal to in root 3 plus 1 is equal to 4. So square root of 4 is equal to 2. So the square roots implies the square roots are from this formula plus or minus in root mod z, that is 2, x is equal to plus, x is equal to root 3, here x is equal to root 3 and divide by 2 minus I 2 minus root 3 divided by 2. So this is the square roots of root 3 minus I. In this way we can find the square root of any complex number, and we can easily find the square root of 2 plus root 3, which we have discussed when we have studied in the first semester surds. We can find the square root of any surd by a simple formula. So if we want to find the, after all we will get the answer is, the square root is given by plus or minus root 3 plus 1 divided by 2 minus I root 3 minus 1 divided by 2. So 2 is here, okay, and the square root of in root 2 plus root 3, that is equal to root 3 plus 1, and the root of 2 minus root 3, that is root 3 minus 1. So in this way we can find the square root of any given complex number. Okay, so this technique we have studied in the previous terms. Okay, so now this is the idea of finding square root of a complex number. Now I am quickly moving toward last topic of the complex number, which is the De Moivre's theorem. This is the small introduction of De Moivre. The Abraham De Moivre was a French Protestant who moved to England in search of religious freedom. Okay, this is the some introduction of De Moivre, and now our idea is to discuss the De Moivre's theorem, which is very useful in so many examples of complex numbers. So De Moivre's theorem is given here. De Moivre's theorem is equal to, is given by cos theta plus I sin theta raised to n is equal to cos n theta plus I sin n theta. Here remember that the formula works for all rational numbers, and we can put n is equal to positive integer, negative integer, or we can put the rational numbers as well. So cos theta plus I sin theta is equal to cos n theta plus I sin n theta. Okay, so this is our de Moivre's theorem. Now let us try to solve some examples of simplification using de Moivre's theorem. Let us look at one example. Okay, example is simplify example is to simplify cos theta plus I sin theta upon sin theta plus I cos theta whole raised to 4. Okay, so we need to simplify this this expression. We want to simplify here. First of all, this one is equal to, we can write this is cos theta plus I sin theta raised to 4. Okay, and in the denominator we can write sin theta plus I cos theta raised to 4. Okay, so here we can directly apply the de Moivre's theorem, because cos theta plus I sin theta raised to n, that is equal to cos n theta plus I sin n theta. So we can write here cos 4 theta plus I sin 4 theta. Okay, which is for the numerator, and here this is not the general format. Here sin theta plus I cos theta. So first I will convert into cos and plus I sin form. So we can write here cos pi by 2 minus theta here, because cos pi by 2 minus theta is equal to sin theta plus I sin pi by 2 minus theta, that is equal to cos theta whole raised to 4. Okay, so by simplifying this one we will get that is equal to cos 4 theta plus I sin 4 theta upon, now I can apply de Moivre's theorem in this expression. So this is cos 4 into pi by 2 minus theta plus I sin 4 into pi by 2 minus theta, because cos theta plus I sin theta is equal to cos n theta, that's 2n is equal to cos n theta plus I sin n theta. This is the de Moivre's theorem. So I can multiply 4 with this part and this part by de Moivre's theorem. So I will get here cos 4 theta plus I sin 4 theta upon cos, this is 2 pi minus 4 theta plus I sin 2 pi minus 4 theta. Okay, is equal to 2 pi minus 4 theta. So I will get cos 4 theta plus I sin 4 theta upon, this is cos 2 pi minus 4 theta, that is equal in the fourth quadrant, 2 pi minus, that is in fourth quadrant. In the fourth quadrant all STC. So in the fourth quadrant cos is positive, the answer is here cos 4 theta, and in the fourth quadrant sin is negative. So here this is equal to sin minus sin 4 theta. Okay, so if I apply here again in the reverse side this formula, then I will get here this one is equal to cos 4 theta minus cos 4 theta plus I sin 4 theta upon, I can write here cos 4 theta plus I sin 4 theta raised to minus 1, because here minus 1 shows that cos minus 4 theta, that is equal to cos 4 theta, and sin minus 4 theta, that is equal to minus sin 4 theta. So this is equal to cos 4 theta plus I sin 4 theta raised to minus 1. So I can write here cos 4 theta plus I sin 4 theta raised to square, because if this one goes in the numerator, then this is equal to cos 4 theta plus I sin 4 theta. We have already cos 4 theta plus I sin 4 theta in the numerator, so I will get cos 4 theta plus I sin 4 theta square. And if I again apply the De Moivre's theorem, cos theta, this is now our theta, this is now our theta, cos theta plus I sin theta raised to n, this is equal to cos n theta, this is 2 into 4 theta plus I sin 2 into 4 theta. I have applied the De Moivre's theorem over here. So cos n theta, that is equal to cos 8 theta plus I sin 8 theta. So this is the simplification of that given expression. So using De Moivre's theorem in this way, we can simplify the any complex expression. Okay, so in this way we can solve the example. Now main idea is to find the nth root of any complex number using the De Moivre's theorem. So now I am going to move for solving the examples of finding nth root of a given complex number using De Moivre's theorem. So let us look at the example here. So question is obtain all possible values of minus I raised to 1 by 4. So I want to find the fourth root of minus I. So first, what is the idea of finding the values of this term? For that I need to convert this is 0 minus 1 into I, which is in the x plus iy form. But first I will convert this part into the polar format, by which I will get cos and sin format here, so that I can apply the De Moivre's theorem. So first I want to say that here z is equal to minus I, which is equal to 0 minus I into 1. Okay, so directly we can here get the value of r, value of theta, and then we can convert this z into polar format. But if we want to convert it in easily, here the cos pi by 2 is equal to 0, but here the y is negative, so y is negative, so I will get here cos minus pi by 2 plus I sin minus pi by 2. Okay, right? Cos is 0 and sine is -1. So we know that at minus pi by 2 sine is -1 and cos is 0, and we are going for the principal argument, so that I have taken minus pi by 2, not 3 pi by 2, because when we want to take the principal argument, it must be between minus pi to pi. We know that at 3 pi by 2 cos 3 pi by 2 that is equal to 0 and sine 3 pi by 2 that is equal to -1, but I have taken here minus pi by 2 because for the principal argument we need the value of theta in between minus pi to pi, so that I have taken here minus pi by 2. We know that the place for the minus pi by 2 is as same for the 3 pi by 2. Okay, so here the answer will be cos minus theta is equal to cos theta, and sine minus theta is equal to minus sine theta. Okay, so this is equal to minus I sine pi by 2, right? So now if I want to use the De Moivre's theorem, then here we have I again going to write, I have got here z is equal to cos minus pi by 2 plus I sine minus pi by 2, and z is equal to, this is z is equal to here minus I. We want to find minus I raised to 1 by 4, so that is equal to z raised to 1 by 4, which is equal to cos minus pi by 2 plus I sine minus pi by 2 and raised to 1 upon 4. Okay, so by De Moivre's theorem, cos theta plus I sine theta raised to n, that is equal to cos n theta minus I sine n theta. Okay, and here I can write in this way. For the general value of theta, I will write here in the form